Artificial General Intelligence, AGI. It's one of those terms that sounds like it's been ripped straight out of a sci-fi movie, right? A machine that can think, learn, and reason just like a human, or maybe even better. But this isn't fiction anymore. So what's the real story? Let's dive in and break down this incredibly complex and fascinating journey.
So, this is the big question, isn't it? The one on everyone's mind, from tech billionaires to the researchers in the trenches? For decades, AGI felt like this super distant dream. But lately, it feels like that timeline is shrinking at a mind-boggling pace. So the question is, how close are we? Really?
I mean, just look at this. It's wild. Back in 2020, when GPT-3 was the new hotness, the experts were saying, yeah, maybe 50 years. Then, boom, ChatGPT hits the scene and suddenly that number drops to 18 years. And now, some of the latest forecasts are talking about just 5 years. That acceleration is exactly why this story is so urgent and so compelling right now. Okay, before we get too far ahead of ourselves, let's make sure we're all on the same page. What is AGI? We're not just talking about a smarter chatbot. The working definition, the one popularized by folks like OpenAI, is an AI system that can outperform humans in most economically valuable work. It's an AI that can learn and master pretty much any intellectual task you can throw at it, just like a person.
But here's the thing. Getting there is not a straight line. In fact, there's a huge debate raging inside the AI world about how to even do it. It's a true billion-dollar question, and it's all about the fundamental path we need to take.
And this debate really boils down to two competing philosophies. On one side, you have what you could call the more compute camp. Their belief is that we can basically brute force our way to AGI. Just keep scaling up the processing power, keep feeding it more data, and we'll get there. But on the other side, you have the new ideas camp. And they argue that all the computer power in the universe won't matter if we don't have a fundamental breakthrough in how AI actually thinks.
Now, the more compute folks, they've got the receipts. Before 2010, the amount of compute power needed for top AI models was doubling every 2 years or so, kind of like Moore's Law. But after the deep learning era kicked in, that timeline collapsed. It started doubling every 5.7 months. That's not just growth, that's an explosion.
Ian Bratt from ARM really sums up this point of view. He's talking about a future where everything is cognitively enhanced, and to get there, we need a huge step function increase in compute. The logic is pretty simple. More power equals more smarts. And when they say huge, they are not kidding around. Some estimates put the compute needed for AGI at over 10 to the 16th power teraflops. That's a number so big, it's honestly hard to even visualize. That's the sheer scale we're talking about here.
But what if we're just building a bigger, faster ladder, but it's leaning against the wrong wall? AI researcher Francois Chollet has a completely different take. He says, I don't think compute is the bottleneck. The bottleneck is really ideas.
So what's the proof for that argument? Well, it comes down to a single, pretty shocking number. Today's most powerful AI models were put up against the test designed to measure real, novel problem-solving skills, not just stuff they've memorized. Their score? 0. A flat 0%.
And that 0 really reframes the whole problem, doesn't it? For Chollet, intelligence isn't about how much you know. It's about being able to recombine what you know to solve new problems you've never seen before. And here's the kicker. If your system scores 0 on that skill, just making it bigger and faster might just give you a bigger, faster system that still scores 0.
So this brings us to a really interesting place. It seems the answer isn't more compute or new ideas. It's probably both. We've got to move beyond just brute force and figure out a smarter, more efficient way forward.
And let's just get real for a second. For all the incredible hype, there's still a long list of things we humans do without thinking that AI really struggles with. I mean, from understanding the subtle nuances of language and emotion to the insane fine motor skills you'd need to, say, perform surgery. These gaps show us we've still got a long way to go.
So how do we build that smarter path? Well, a really key idea is something called heterogeneous computing. It sounds a little technical, I know, but the idea is actually super simple. Instead of just throwing one giant, powerful chip at everything, it's about building a balanced system. It's about using the right tool for the right job and focusing on being efficient, not just powerful.
Think of it like a toolkit. You use your general-purpose CPUs for all the normal stuff, then you bring in the heavy-duty GPUs for that massive parallel processing you need for AI training. And then you use these super specialized chips, NPUs, or neural processing units, that are designed to do one thing and do it with incredible efficiency. It's just a smarter way to use our resources.
But smarter hardware is only one piece of the puzzle. As AI expert Henry Eisner points out, we might need a whole new blueprint for the software too. I mean, think about it. The huge leap we just saw in generative AI was all thanks to a new architecture called the transformer. The next leap to AGI, it might need another breakthrough just like that.
And you know, this whole process is forcing us to ask an even bigger, more philosophical question. What are we even aiming for? I love this quote from Raman Chaudhary, who points out that we don't judge a monkey on whether it can pass a calculus exam. If we only focus on our narrow idea of human achievement, we might be missing a whole spectrum of what intelligence could even be.
So as we look down the road, the question is starting to shift. It's not just how do we get there anymore. Now it's becoming, what are we really building? The journey itself is making us rethink the destination.
So what's the takeaway here? The real journey to AGI isn't just one single path. It's a combination of smarter, more efficient hardware and brilliant new software. It's going to require some fundamental new ideas about what learning and reasoning even are. And maybe most importantly, it's forcing all of us to broaden our definition of intelligence. You know, this whole quest might end up teaching us just as much about ourselves as it does about machines.
Which leaves us with one last, kind of mind-bending thought to chew on. If we actually succeed, if we build this new kind of mind that doesn't just copy ours, but operates on totally different principles, will we even recognize what we've created as intelligence? Something to think about.